just push it down. Yeah, see, you can tell me if it's showing me or not. So Kirsten will thank you mightily, and all the other people who are not here also. Okay. Yes, thank you. So you see what I'm pointing out here, that for this model, the maximum lift was about 1.25, because that's the highest point where that red curve was. If we added up all of these values for the red curve, we'd get a cumulative 1. So I wish JUMP would have an option to show cumulative. That's one of the few things that I would say they could do better. Yeah. Okay, any questions about the lift curve? Okay. So now we're going to come on to when we have these two different types of errors. So obviously it costs us a different amount of money, right, depending on which type of error we have. So maybe what we would like to do is change the balance of where the errors are between the type 1 errors and the type 2 errors. Okay, so in order to do that, we can see what's called the ROC curve, or the ROC curve of this model. Radio operator curve is what ROC curve stands from, because it comes from a technology that was developed during World War II, during the time of radar. So it's not entirely understandable. In fact, when I first started to look at this, it really didn't make any sense to me at all, to be perfectly honest with you. And so, but as you can see on this screen, the best classification has the largest area under the curve. So this gives us another way of comparing models. But what does it mean to have a large area under the curve? So I'm going to try to explain this to you. Let's see, what have I got coming up next here? Okay. Yeah, so let me just go through this and start with some preliminaries here and then come back to how to read and understand this curve. So if you think about our confusion matrix, right? We've said this already. In the upper left-hand corner, we're saying it was negative, and it was negative. So no response, that's a true negative. In the lower right-hand, we said they would respond, and they did respond, that's a true positive. In the upper right-hand corner, we have a false positive. Why? Because we said that they were going to respond positive, but they didn't. So we said it was positive, but it wasn't, so we were wrong. It was a false positive. And the same thing with a false negative over here. So once we understand that terminology, then what I've got on this set of slides here is just showing you to point out where the false positives were and the false negatives were. I'm not sure I need to elaborate this too much, just going through this. So the rate at which we find our true positives is called the sensitivity. And if you take the total of the actuals across that bottom part of the matrix, then we've got whatever our predicted positive was, the true positive divided by the actual positive, that says how sensitive the model is. So if we got every single one, our sensitivity would be 100%. We were able to find every single case that we were looking for. So our model is very sensitive. So that one, I think, is kind of relatively easy to understand. We would like to have models that are very sensitive, wouldn't we? Right? The problem with a highly sensitive model is we can also pick up a lot of things that are incorrect as a result of that. But here's a calculation of the sensitivity given the data that I have here, 284 true positives, but I had 561 that I classified wrong, so my sensitivity was only 33%. I only found 33% of the total that I could have found if I'd had a perfect model for that. Okay? We agree? We're okay? All right? So now let's look at the other side, which is called the specificity of the model. So in this case, what we're looking at the true negatives divided by the total actual negatives. Now, I think I can understand the term sensitivity. Well, why specificity? That one I don't particularly understand, and so I can't explain that to you. If you find an explanation for that, why they chose the word specificity, maybe they wanted something that was similar to sensitivity but wasn't exactly the same, so they chose specificity. But in any case, that's showing you how well we can predict the true negatives. And so here, in this case, our specificity is, we got 7,000 out of about 7,200. So we got 99%. Clearly, we're doing a lot better with our specificity here than we were doing with our sensitivity. Sensitivity, we got 36% or 33%. Here we got 99%. So what can we do with these numbers? Well, if we think about what is that specificity rate, 1 minus that, we're really looking at the false negative quadrant. That is, 1 minus the specificity is the false positive rate, the rate of false positives that we get. All right, now why did I throw that in? Just to confuse you? No, I threw it in because when we get to the ROC curve, what do we have? We have on one axis the sensitivity, and on the other axis 1 minus the specificity. So what the ROC curve is doing is it is graphing the trade-off between when we detect false cases properly and when we detect true cases properly. So at any point on this curve, we're going to have a different balance between false, correct false and correct true. That's what the ROC curve is. Let's see. And so if you remember, we've been talking for several hours now, and we brought up this issue of the cutoff point. We've said that these models all are using a cutoff point of 0.5. It turns out that when you change that cutoff point from 0.5 to something else, you're changing the balance between the false positive rate, the true positive rate, the false negative rate, the true positive negative. In other words, you're moving along the ROC curve. That was the thing, that when I finally understood it, it was like, oh, okay, now I understand what the value is of that ROC curve. And so here it is. I took out the red line. The red line is about the not fraud cases. The blue line is about the fraud cases. So I took the red line out just so we don't confuse anything for this. And I'm actually going to show you how we move along the ROC curve with some calculations here. So blue line is fraud. The bottom is how often we get false positives. So notice that when we get all the way to the very top here, that would be a situation in which we have all false positives and all, but we get all sensitivity would be 100%. So we would find all true cases. So that means we just classified everything in one as our response. So in the upper right-hand corner, that would we would be finding everything we want to see, but everything else would be in error. You know, if we were over in this corner over here, we would be doing the best we could possibly do. We'd be finding everything and making no mistakes. So if we're down here at 0, 0, we're finding nothing and also making all mistakes. So let's add sensitivity is 0.336, false positive rate 0.009. That's the one I was just showing you, and that gives us 1 point on the curve. So all we have to really do is figure out how can we change that balance in order to move on the curve. So this is how you read it. If we get this many true positives, we get this many false positives, and then where do the other points come from? Where do you think, if you haven't looked ahead, where would you think the other points are coming from at this point? This is still good. Thank you. How did we get that balance? How did we derive that number, 33% or 99%? We looked at what? I just showed you a bunch of examples that I kind of blew through rather quickly, but what was I showing you to get those numbers? It was the confusion matrix, right? Remember just a second ago? I just showed you a whole bunch of confusion matrices, right? It's showing you where we got those numbers, 0.9% of false positives, right? So we got this by using that confusion matrix. That's 1 point. So what happens? We vary the cutoff point that changes the confusion matrix, and then we move along the ROC curve. So this is the sensitivity, and this is how many errors we're picking up. This is how well we're finding what we want to find, and this is how many errors we pick up in the process. That's another way of looking at this. Okay, any questions now? I know this is a tough one. This is maybe one of the hardest concepts that we have in the whole class, to really follow this. Okay, all right, you're willing to go along with me a little bit farther? All right, so on this one, what I've done is each yellow here, because I've copied data from my Excel spreadsheet where I worked all of this out. The first number is the percentage, that is the cutoff point. Then the next one is the sensitivity, I think. No, the next one is the 1 minus specificity, false positive rate, and the next one is the sensitivity. I probably should redo this slide and make it a little more legible. I apologize for that fact, but in any case, it's showing us 1, 2, 3, 4, 5, 6 or so different points where I varied the cutoff point, and I've gotten different balances in my confusion matrices for this. So, what does this mean in practice? All right, so here I've added a little bit more to this. I've said we have about 10,000 cases of fraud. I've said that if we don't pay the fraud, we save ourselves $2,500 for not paying, but we incur a cost of $250 of an administrative cost. So in this particular case, we classified everybody as fraud. So we got all 845 cases right, 7,184 wrong. We misclassified 89% of the cases, but we saved a payout of $2.3 million. We have an administrative cost of $2.2 million, so our actual savings is about $131,000. Now, my question for you is, would we actually use this model? This is kind of the reverse of the naive model. This is classifying everybody as fraud, just so we get every single one of those darn people that defrauded us, right? We're going to go after everybody, so we'll get every single one. Yeah. So would we ever do this?
So you falsely accused 89%? No.
Yes, we would never falsely accuse 89%. This would be a blunder of intense magnitude for our company, because notice that I left the ill will blank.
That's
question mark.
Yeah, I was going to say
yeah,
PR.
that could drive us out of business right there, the ill will. So clearly, this point, see where this point is up here on the ROC curve? We're not going to situate ourselves there. We're not going to set the cutoff point so that we get all the way up there. If I move down the ROC curve, okay, so now my cutoff point is 0.07, which, remember, that means that in a node, rather than saying we classify as fraudulent as if it's 50% more, we'll classify as fraudulent if it is 7%. All we have to do is have 7% cases of fraud in that node, and everybody gets classified as fraud. If I do that, then look at that. I make $435,000. I've almost 3 times more than I made the last time on the last one. Can I do this?
No.
Why? I can't falsely accuse 57% of my customers? No, not yet? Okay, let me move down. All right, so now I have saved $1.4 million in my payoffs. I'm costing me $700,000 in administrative costs. I'm up to a savings of $723,000, and I'm only falsely accusing 28%. Can I do that? No, still can't do that. But notice how far down I am on the ROC curve. So again, if I had a model that has a curve that's bowed out even higher, my choices could be better in terms of the trade-offs that I have. All right, I'm going to move down to the next spot. Now my cutoff is 0.1, and I'm now making an actual savings of $784,000, and I'm only falsely accusing 0.9% of my customers. Yeah. Can I do that? Yeah, maybe I can do that. So that's the thing, is I would have to factor in what I can do in the actual business world, right? Let's say if I move it down even further to 0.5. So this is the 0.5 that would be the standard that people would use, right? If I didn't know anything about varying the cutoff point, I could still make $775,000. I'd be falsely using 0.8 instead of 0.9. So actually this is probably be better. You know, I'm making about the same amount of money, but I'm not, you know, accusing a few less people on this. And so this is why people would say, okay, maybe 0.5 is a good number. You know, I made the numbers work out pretty well in this case, but still. Yeah. So let me show you how you would go about getting that in practice in JUMP, okay? Because I know that I was just doing a whole lot of hand waving here, right, saying changing the cutoff point, blah, 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 right? So let me just show you how that would actually work. So what I'm going to do is I'm going to create one more model here. I'm going to say analyze modeling partition. I'm going to put in my outcome as my Y response, and I'm going to put in everything, but I'm not going to put in attorney this time. Gender, let's see, credit score, newly insured, total monthly income, and my validation column is going to go in to validation. I've remembered it this time. I'm going to click color points. I'm going to click display options, show split count. I'm going to click go. And it looks like I got the same model I got last time, only one split. That's really not going to help us that much to demonstrate this. So you know what I'm going to do? I'm going to let myself throw the attorneys back in, and even though we know we can't use attorney, it's forbidden, but I'm going to throw it back in. Can I do that? Will you allow me to do that?
It's forbidden.
You're cheating.
Just for this time. This once, just this once. We were talking about dad phrases, just this once. Okay, so I'm going to hit go. And okay, there we go. We've got about 2.2 for our R squared. Looks like our model is pretty well fitted. If I turn here and I look at my show fit details, I'm going to see my 3 different training, validation, and test classification or confusion matrices down here. All right, now what I'm going to do is I'm going to do something that you can also do in Jump. I'm going to go back to my main menu and see how it says add-ins up here. Okay, right now I have an add-in called Data Mining Tools. You don't have that, but you can put it in. If you say File and Open and download something from Springboard that I've given to you there, let me see. So, wait, why is it saying results here? Documents, video featuring 601, spring here. See this one that says data mining tools working.jmp add-in. So that's the file that you can download from Springboard. Put it somewhere where you can find it on your computer, and then just open it in Jump like you would open any other file, and it should install. Here it says it's reinstalling it. I'm installing it, and I now have it as my add-in. Hopefully nothing bad will happen when I reinstall it. Right, it's reinstalling it. Okay, so that's step 1 that you need to do for that. By the way, I don't think that I've given you any written documentation. I'll write something up for you so that you have a guide of how to do that. And then I'm going to go back to my model that I just created, and I have to do one more thing, and that is to say I have to save columns, and I have to save the prediction formula for this. So save columns, save prediction formula, just like you saved a prediction formula for the multiple regression. And if you go back and look at the Jump table here that we have in the fraud data, you'll see going all the way out to the right-hand side, I have probability equals fraud and probability equals not fraud.
Can you repeat the last step, please? Yeah,
the last step again was that I went to my model, and then I said the red triangle, I said save columns, and I said save prediction formula. So, having done that, I can now go to the add-in, and I'm going to say go to Data Mining Tools, and I'm going to go to the very last thing which says alternate cutoff confusion matrix, the very last one. So they say I'll try to write something up so that you have a guide for this. I'm going to click on that, and I'm going to have to fill in 3 different things on this. I'm going to have to fill in what my target variable was, so that's going to be outcome. I'm going to have to put in one of my 2 predicted value columns, so I'll put in the predicted value for fraud, and then I'll have to put in the name of the validation column. So here we go. I'm going to put most likely outcome. By the way, if you can't see this very well, you can expand it out so that you can see what the names of the columns are better. So I'm going to put the probability of fraud in there. I'm going to put my validation column in there. Yes, that's okay that the validation column has missing values. Don't worry about that. And then I'm going to put my outcome out here. And I'm going to click on specify a range of increments. So I'm going to go from let's say 0.05 to 0.3. I chose that because of what I had before that I just showed you, where it looked like I needed a real low cutoff point to find my cases of interest. And the increment I'm going to do is 0.05. And now I'm going to say OK. All right, it is one by one calculating all of those confusion matrices. This is such a sweet thing, because you know what you had to do before we had this? You had to do it manually, one by one. That's why I used to make this a big part of an extra credit assignment for people who wanted to do it. I've had to change the extra credit a little bit so that it wasn't so easy now, because this has now become much easier. But notice when I have the cutoff point of 0.05, look at how few fraud cases I'm picking up. So clearly 0.05 is not helping me very much. When I get up to 0.03, I'm doing much better on the fraud cases. And I can open up these boxes down here to look at the actual percentages here. So in this case, how many people will I be falsely accusing? Oh, wait a minute. Do you notice something different about this? There's a key thing you have to notice about what just came up on the screen. Absolutely critical. I don't know if you can see it very well from there. You're young, so you should have good eyes right now. But I'm sorry that the screen is so small. It says predicted fraud, not fraud. Outcome fraud, not fraud. How is that different from the way that we've been looking at the data? We've always had the class of interest be in the lower right-hand corner, not the upper right-hand corner. It sorted these in alphabetical order. So by sorting them in alphabetical order, we're going to have to reverse the way that we're looking at the output. So it's saying that we found 35% of the cases of fraud. We missed 64% of the cases of fraud. Up here, when we had 0.01, up here, it looks like we got 431 out of the 432 cases of fraud. That's more like what I was showing you earlier. For a moment there, I was confused myself. The confusion matrix confused me there. We got 99.7% of our fraud cases, but we are going to, in fact, to be accusing a huge number of people wrongly, right? We're going to accuse 99.8 wrong. So you probably, obviously you may not be able to follow along exactly what I'm doing right at this point, but as I say, I'll write up a little guide so you can follow these instructions if you want to. But the point is, this is what I do want to make sure you understand, that you're moving along that ROC curve. And so go back to our curve here. If we go back to the original curve that I showed, right here. And what is this curve showing us? Various different models. So if we're on model or method 4, and you've got that blue curve that's going all the way out there, we don't have to accept such a big trade-off between getting it right and then the cost of getting it wrong. Because we are closer, as close as we can get to that upper left-hand corner when we would have perfection. And then all it is a matter of finding the place on that curve that gives us the best result. So if we're looking for cancer patients, and it's really 1 out of 10,000 that we have to find, and there's no cost to misidentifying people, we might find this at one extreme end or another extreme end of that curve, as opposed to an insurance company, we might have a different trade-off for that. So that's why I'm saying if you don't take into consideration an understanding of the cutoff point, you're missing a large portion of what the data mining is all about. Any questions at this point about what we just saw, or any more questions that you have?
Where do I download it? What am I downloading?
Okay, in Springboard, let me call up Springboard again and make sure that you see what it is that I've given you here. Let's see. So in session 03, I think I put it under, let's see, where did I put it? I know I put it somewhere.
It's under tutorials.
Oh, it is under tutorials? Oh, on partitioning?
On logistic regression.
On logistic regression, God knows why I put it there. Oh yeah, there it is. All right, that was definitely not the most logical place to put it, but it is there, under tutorials, under logistic regression, and it is this thing that has the dash, and it says data mining tools working, and you can just download that, and it's a jump add-in file, and then you should be able to open that in jump, and it should install that for you. Otherwise, you can do it manually. I think I do have a tutorial on here about how to do it manually yourself. You can use column formulas. You can even do what I did, which was to set up a spreadsheet that calculates it out for every single row, and then you could put in any cutoff point you want. And, so it can be done manually. You don't have to necessarily do it this way. Okay, well, that is the end of what I wanted to cover for this portion of the class. So what we're going to do next is we'll take another quick break now. Let's come back at about 2 o'clock, I think. And then we'll talk about logistic regression. And so I'm going to introduce another whole technique. So get ready for the fact that you're going to get one more chunk of information today. And then we'll work on another in-class exercise. And this is the one that's based on tennis. So in this case, the subject matter is Andre Agassi. And this is actually real data that I had access to from the early 1990s. And so again, if you read the case over, you'll see, and I want you to try to figure out how to give advice to him about what shots he should be hitting. So we have our resident tennis expert here. The fact that Paul was here was one of the reasons why I decided to resurrect this assignment rather than just having you do another thing with the fraud data. Thought it would be more fun if you had something that was a little bit different. So I'm sure that Paul would be happy to answer your tennis questions during that portion of the class. So let's take our break and we'll come back at 2 o'clock, let's say, and continue.